Hello, this is our Lab 5 submission for CS684 Embedded System Line Following Robot. In this lab, we have implemented line following, obstacle navigation, obstacle avoidance, and parking. So here is our heptagon code. This is our parameter section. We have defined multiple parameters like KP, KI, KD as global variables here. Then we have multiple utility functions like calculate PID, weighted sum and sensor weighted average functions. Then we have shape motor update, so we update the motor speed in range 0 to 100. Then we are normalizing values, so we are basically scaling the sensor values between 0 to 1000. Then we have update means, update max to update the minimum and maximum of each sensor. Then max and ABS absolute value of an integer value. And also you have PID error to speed, that maps a PID error to a speed. This is our main node. It takes 5 sensor inputs. IR value is these two sensors at the front, 2 IR sensors, and these are obstacle right and obstacle left. And with these inputs, it returns velocity left, velocity right, and direction. As you can see, we have state calibrate, idle, start, white on black, that is white line following, black line following, intersection, obstacle avoidance, and parking states here. These are our primary states. In calibrate, we are calibrating the sensors. Then idle, that it waits to be put on the start line, and then start. So once when it is on the start line, it goes straight for some time. It keeps going straight. White on black, so it is our white line following state or mode. Here we are calculating the PID and updating the motor speeds. And for sharp turn, we are using this state. Then we have black on white, so simple PID error, and we are applying to the different motors. And if intersection is found, that is any consecutive 3 sensors are low, that is 3 sensors are not black, then we go to the intersection state. And if IR value is not equal to 0, that is greater than 0, then we go to obstacle avoidance. In intersection state, there is a counter state where we count which intersection we are on. Depending on the counter, we in this entry state, after the entry state, we choose to go right, left, or straight. And in these states, right, left, etc., we are defining the direction and speed of the motors. Similarly, after intersection, we return back to black on white line, or if there is an obstacle, we go to obstacle avoidance stage. So in obstacle avoidance stage, we are fast wait for some time for the obstacle to move. If obstacle moves, we follow the obstacle. Then if it doesn't move, then we are going to full right, 90-degree right turn, and then we go straight for some time. And after that, we go slightly right and slightly left in such a way that it slowly basically follows the edge of the object. And when it reaches back to the black line, using this start and exit end one into states, we catch the line back. At the end, we have the parking state. So in the training stage, we are basically calculating the threshold required, this parking cycle threshold, we are calculating it. And in find space, in the left and right, if there is no obstacle found for this threshold value, then we try to park on that side. So in this go well these states, we go straight for some time, then we come back reverse to check there is no obstacle, and then we rotate for some time. Here we are rotating for some time, that is like 90-degree, and then we go back reverse and to enter the parking stage, and then we stop. So here I will generate the C code from this heptagon. So there is no error, and this is our supervisor.ino code. Here we are mentioning the ports and the material sensor and the memory for our heptagon code. In setup, we are initializing the pins and the devices. Then we are calibrating our IR sensors, and in the loop that runs for infinitely, we are reading the sensor values, and we are passing those sensor values to this line follower main step function. Through this function, our heptagon code actually runs, and with the output value, that is this raise value, we are controlling the motor. So this is our supervisor.ino. Now I will connect this motor and upload the code. So here the code is being built already and it is uploading. It is uploaded. Now I will run this on the arena. So it is now calibrating. Now it is waiting to be put on the start line. So it is on white on black line mode. That is basically white line following. Here the color switch will happen. Intersection 1, intersection 2, and obstacle is detected, so it wait for some time to obstacle the move. If obstacle has not moved, so it is navigating around the obstacle. Now it has caught the line back, so it is following the black line. Now it has moved to the parking state, so it has found a clear space and it has parked and has stopped. Thank you.